10.3 number 5. So you've got a position vector defined in a time, and we're supposed to draw the graph of it, find the velocity, acceleration, speed, direction, and write it as an equation. So just graphing it, we could do it by hand, just by plotting a whole bunch of time, or starting at 0, pi over 4, pi over 2, and so on, and create a graph parametrically. I'll just show you. This is all you would really need to know how to do here. It would be on your calculator, so make sure you go to mode parametric, which I already did, and then I'm in radian, so I'm good to go. Go y equals, enter in it parametrically, which I've done, and then I'll do 0.6. So I'm at home now over spring break making videos, so you may hear funny things like Coco the dog in the background, or Remy the dog. Alright, so I graphed it. It looks like an octagon right now, which means it's probably not an octagon. I just have to decrease my interval of time, because it's just plotting points here and here and here and so on. So if I make my t step smaller, like 0.02, then it should be a smoother graph. It'll plot the points slower because it's plotting more points, but it does make that shape. In fact, I don't know if that's a circle or an ellipse. I'm going to do a zoom square, and we'll have a better idea of the shape of it. Not that it really matters for this problem, but this will have x and y axes in the same scale. Okay, so it is an ellipse with a vertical major axis. So that would be what you get when you plot this. So you can see by inspection from our ellipse, our horizontal radius, if you want to call it that, would be which is half of the horizontal axis, is 2, and our vertical one is 3, and you can see that from our equation, that's going to be your horizontal half of your minor axis, and there's your half of your major axis. Alright, so I think I'm done with letter A. Find the velocity. So the velocity requires a derivative. So our velocity vector, v of t, would be derivative of the horizontal, which is -2 sine t. So there's an I, an ugly one. And then the derivative of 3 sine t is 3 cosine t j. So then our acceleration is just another derivative, -2 cosine t I minus 3 sine t j. There's my acceleration vector. Speed is the magnitude of velocity, or absolute value of velocity. So the velocity is right there. It's at pi over 2. So you could find, so at pi over 2, our velocity, sine of pi over 2, which is 1, so it's -2. Our velocity at pi over 2 is -2 comma, and cosine of pi over 2 is 0 times 3 is still 0, so that's -2 comma 0. So if I wanted to know what the magnitude of this is, you could do the Pythagorean theorem. So it'd be, generally it'd be the square root of -2 squared plus 0 squared. So -2 squared is 4, square root of that is 2. So our speed is 2 units per time, whatever we're in here. Another way to look at it is the velocity vector is -2, 0, so it's -2, 0 there's my velocity vector. If I go -2 to the left, what is the magnitude of it, or how long of a vector is it? You can see that it is 2 units long, which is what we got using our formula. It confirms that our speed is 2. Direction. The direction is a unit vector in the same direction, so you can see if that's my velocity vector, my unit vector would just be the same direction with a magnitude of 1. So you could see that my unit vector is -1, 0. That's my unit vector, which is also my direction. Another way we could have done that, we just happen to have a vector that landed on the x-axis, so it's a little bit easier to find the direction vector. Generally, you take the velocity vector and you divide by the speed. So our velocity is divide each component by our speed, which is 2. So we end up getting -1, 0 anyway. So there's my direction vector. Okay, so then we have to write our velocity as a product of speed and direction. Our speed we know is 2. Well, okay, so our velocity is -2, 0. Equals our speed, which is 2, times our direction vector, which is -1, 0. So you can see that our velocity is equal to our speed times direction. If you distribute that, you would get our velocity. So there it is in that equation.